Okay, hello everyone. We can start. I'm Lorenzo Ferri, and this is Lorenzo Verardo, and we work for Ex Machina, a consulting company here in Lugano that's been working for over 20 years. Today, we're here to talk about a journey that we did in development about a real-world problem that is city urban traffic, and how we built this simulator with open tools like OpenStreetMap and SUMO and Godot to simulate and make intervention on the city streets. So planning is not enough today. We need to ask a real question and have a way to test them. And what we wanted is a tool that can allow us to make decisions. For example, if we close a certain street, how will this impact the traffic, and what are the costs that comes with it? So we decided to build something that was data-driven by taking data from the real world with OpenStreetMap and make the simulation as realistic as possible.
We started with a question, how we can visualize, simulate, and modify the city roads to simulate the environment. So the first idea was to create a graph to represent the city with connections between nodes that are the road and with directions to represent the one-way road or two-way roads. So we started with a web app. We are front-end developers, so we started creating a React app to show the data that we take from OpenStreetMap. So we parse the data to show them on the web app and render each node and each edge to create the map of the city. Then we import the directions of each street, and we started to simulate the vehicle roads and show a heat map to represent the most congested areas. The last step we did was the edit of the roads to compare the simulation, so we can start the simulation, check the cost of the simulation, and after some changes, check if the simulation is better or worse. This is the first version of the software. So this is a React web app with a small town with some roads. So in this simulation, there are roads and with the directions, and the red ones are the most congested roads, and this is an analytical approach. So we can see inside the simulation each single vehicle, but only the flows. So we wanted to change the approach to simulate the behavior of a single vehicle. For example, the acceleration, deceleration, the stop, the traffic light, and so on. And then also the simulation started to lag when we increased the number of vehicles, and we applied this example on the larger city like Lugano, for example.
Yes, so what we wanted really was to build like a real simulator where each car is its own entity. And to achieve this, we decided to use Godot. Godot is an open source game engine programmed in GDScript, a Python-like language. And we wanted to code all the logic for the vehicle. So it will stop if there's a vehicle in front of it, accelerate, stop at traffic light, intersection, and so on. and also have a custom rule for pathfinding. So we spawn a vehicle with a starting destination and end destination, and we would automatically check for the best path inside the city to reach it. This is what we ended up with the second iteration in Godot. You can see, maybe it's very small, there are some small blue dots that are moving. Those are the vehicles. And you can see there are simulated traffic light where vehicle stops, and they wait for the vehicle in front of them to move forward, and so on. So this is built again with OpenStreetMap data and A* for pathfinding, that it's included in Godot physics. But there are several problems that we encountered during this version. First of all, there are a lot of edge cases when programming something like this. For example, roundabouts have a different right way of handling. Like when you enter a roundabout, you have to give priority to the car on the left, when usually it's different. And also with bigger intersection with like 6 or 7 arms, the logic becomes really complicated. But more than that, there was like a bigger problem that slipped under us when we were prototyping and thinking about the network. And let's take an example. So we said that our idea was to transform the data from OpenStreetMap to this network, to this directed graph where each edge is a street. And if the edge is bidirectional, it means that the road is connected in both ways. Instead, if the edge is one directional, you can go only one way. Let's take a real-world example. For example, this is a street in Lugano near Via Zurigo. And if you know the street, it's one direction in this way and both direction in this way. So we can represent it with something like this if you connect the graph. The problem lies in the fact that if we just look at the graph and follow the rule of the graph, we could take a turn like this, because it's an absolutely valid path. You move from that edge to the center node and then follow down the other edge. But in reality, that is not allowed in this intersection, because there are also external rules for each lane. And at this point, we had 2 options. Either rethink the network with something like, instead of each street being an edge, let's consider each lane being an edge. And that would be an option, but it would increase in complexity a lot with like lane switching and so on, and also all the complexity from before at an intersection. The other option was to choose something that maybe was already built and solved this problem and try to integrate what we wanted to do with the solution. And that's what we did, and we ended up using SUMO. SUMO is an academic standard for traffic simulation. It's used in a lot of universities, and it's also open source. It's a really powerful tool, but we found out that it has also a big problem, that it's, in our opinion, its usability, because a lot of the functionalities are hidden behind a lot of menus and UI, and even simple operation like closing a street or changing the direction of a road are not intuitive, let's say. So our idea was to take the core engine of SUMO and take it as a base, and using C# that it's natively supported in Godot, build this bridge that will allow us to call SUMO, in particular using Libsumo, that is their open source bindings to call the SUMO API. And with this bridge, we can call the core engine while building on top of it a new UI in Godot that would allow us to make it easier to use.
Yeah. After that, we had the simulation working, so we focused on the UI. So we wanted to create a intuitive and clean and simplify the UI, the interface, the UI UX. So we can see the difference between SUMO and our software, the actions in our version is easier than SUMO, because in SUMO we have a lot of options, actions, buttons, and in our version you can just right-click on a road and edit the road, close the road. So it's easier, and it's very simple to learn how to use it. Okay, so before the demo, let's see again the technology stack that we used. We use Godot to the rendering part, so to see the UI, the roads, the vehicles, and using C# to calling SUMO APIs, using Libsumo to communicate with, of course, SUMO, that is the core of the simulation that moves vehicles around the roads. And at least, of course, OpenStreetMap API to get the data for each city and show the data and get also the speed of the streets to simulate the vehicles.
Okay, let's move on to a demo. Let's see if it works. So let me exit. Okay. I need to find the mouse. Or maybe I can do like this without using the mouse. Okay. Okay, perfect. So what you're seeing here is the simulator. It's called One Way, that's the official name. And you're seeing a portion of the city of Lugano. On the bottom, we have some statistics, like the total number of vehicles, the currently active vehicles in the simulation, the cost of the simulation, and about the cost, also the average and the standard deviation of the cost. We can start the simulation, and we will see vehicles spawning around. There, I have a modified road, whatever. We can speed up the simulation to make it faster. So yeah, we can see some vehicles moving. And also, here we have an intersection with the traffic light, and we can see all the traffic light logic working with the priorities and the right way of handling correct. The SUMO does that for us mostly. Given a simulation, we can also look at a heat map of the traffic. We have two options, one for real-time heat map, where it changes in real time where traffic is forming. You can see some red spot appearing and going away where traffic is no longer present. But we also have a cumulative view that shows, in general, the roads where traffic has formed over the course of the whole simulation. This value of cost is given by the amount of time that a vehicle has to wait in front of another vehicle. So when basically queues start to form, this value increases faster, but it will always increase, it cannot decrease. Let's stop for now the simulation and focus on the other point of editing the street. So we said that our goal is to test scenarios. So right now, let's say we are in a standard scenario. We run the whole simulation that lasts for 2 simulated hours in our current configuration, but it's editable. What we can do is, for example, right-click on a street, and it will tell us the street information, if it can right-click. The demo classic. I don't know if it's not focused or what. Let me try to restart it. OK, perfect. I don't know what happened. So we can see the information about a street, like this Viale Carlo Cattaneo. We know the max speed of this street, so that the vehicles follow the max speed, the number of lanes, and the length. We can have some operation. For example, we can close the road. This will make so that the next time we run the simulation, this road is inaccessible for the vehicles, and we can see if closing this road, how much does it impact the cost of the traffic. And we can also restore the road to make it open again. And let's say that we want to change the lanes, so we can make increase the number of lanes or decrease it, or in particular, if we decrease one direction and make the other increase, we basically make this lane one way. We indicate it in purple if there are some edits on the street. And now this way is only one way, and we can test if the traffic is better or worse with this configuration. I think that's it for the demo. Yeah. OK, let's go back to the final point of the presentation. OK. No. See. We wanted the simulation to scale for both a small and big city, so you can import the data from OpenStreetMap, plug it on any city you want, and test the traffic in there. We wanted, as I said, the data is taken from the OpenStreetMap data because we want it to be as realistic as possible instead of building manually the intersection and the street. And also, we are not currently using it, but SUMO offers us a few more interesting metrics, not only just time-weighted, but for example, we could include in the visualization how much noise pollution there is on the street and how much CO2 emission there is. What comes next? This project is currently, let's say, not finished. There are still things that we can include. One thing that we thought about it, and we had some tests, is real-time data. So right now, the traffic that you see is mostly random, meaning that the vehicles, we choose a starting and end position, and they move. But one cool thing that we could do is take real-time data from real-time traffic so that we know for a specific day and a specific time where to spawn the vehicle and where to move them, so that the traffic is more realistic in the street that it forms. And also maybe integrate some AI chatbot so that you could ask about what operation to do on the street. Like if I close this street, what's the best thing I can do to reduce the impact on traffic? And the chatbot could run our simulator, see the numbers that it provides, and tell you the output of the simulation, and offers you some solution. That's it for us. Thank you. If you have some questions.
First of all, thank you. I was wondering, how long did it take you to make this?
Like, it took a while, because as you've seen, there are a few iterations. The first iteration on the web, I think it was a few weeks.
Yeah, a few weeks.
And then when we moved to Godot, it took us roughly a month, a little bit more, to develop the first version that we wrote the simulation, and then another month or so integrating SUMO and saying, OK, let's use their simulation in our visualization. Yes?
Thank you so much. Very interesting. I have two questions. The first question is related to this simulator, or maybe in SUMO. Now, using this simulator, you can close some roads or restore it. Can you change the road, so change within the map? I think it's not maybe possible because it's related to OpenStreetMap. But my question, because it is related more to reverse engineer the question, how should be the architecture to minimize the cost?
Yes, so you can theoretically move the street. There is that function in SUMO. It's in another application we did SUMO that is called NetEdit, and we try to move the street. As we said, it's really complicated. So we don't have that feature in our simulator, but it's technically possible. It's an XML that you have to modify, basically. And your question is very good. The real problem is that very rarely cities build new streets. It's mostly how do we optimize the already present like streets to reduce the traffic, because it's not always possible to build new streets.
Another question I would like to ask about Godot. I don't know it, but why you selected this? I don't know is it whether it is a framework or
yes. So
why,
Godot, it's a game engine, and we chose it because we had a little bit of experience with it, and it's also open source. There's not a really particular reason why we need to use Godot over some other visualization tool. It's just that being a game engine, it's already optimized to draw thousands of vehicles. We don't have to do like object culling optimization so that only what you're seeing is being rendered. So it would allow us to not focus on rendering optimization, but just simulation optimization.
Thank you.
You're welcome.
Okay. I try with the voice.
Yes. Yes.
So they will be super fast. Red color in semaphores.
Yes.
Like, is something that you can parameterize and check what is the... Have you tried? I always ask myself if the 5 minutes of reds are a good idea.
Yes, so here in Lugano, if you drive here, you know that traffic lights are smart, meaning that when you approach it, it will turn green if there are no other vehicles. We don't have that specific feature in our simulation. We have like timed the traffic light, like in most cities in Italy and so on. We can change the timing. It's a property in the configuration. We don't have it in the UI. Currently, we are using the standard timing that SUMO provides for traffic light, but yeah, it could be a thing to try to change that. The thing is, here in Lugano, as I said, it's a different logic, so we will need to implement that first, I think, to test how traffic light behave.
OpenStreetMap also provide a structured data with each timing of the green one, the red one, with a specific order. So if the data are on if there are the data on OpenStreetMap, you can import it and use it.
Thank you.
Thank you.